Roughly 5 billion years ago, before the sun, planets, or moons even existed, there was only a massive, swirling cloud of gas and dust, the remnants of ancient stars. This cloud, known as a protoplanetary disk, was chaotic, with turbulent currents of hydrogen, helium, and trace elements spinning in endless motion. Slowly, out of this vast nebula, material began to clump together, pulled in by gravity. Over time, these small clumps merged into larger and larger masses, each one growing stronger in its gravitational pull. But among these growing bodies, one in particular stood out. It didn't just accumulate dust and gas, it began to dominate the space around it. This massive object had enough material and potential energy to become something much greater. In fact, it was so large that it could have been a star. This body had all the right conditions to ignite nuclear fusion in its core, yet it stopped just short of that transformation. Instead of becoming a second sun, it became something else, something just as fascinating, the largest planet in the solar system, Jupiter. Today, Jupiter remains a giant among giants. Its massive presence has shaped not only its own identity, but also the structure of the solar system itself. Measuring about 143,000 kilometers in diameter, this gas giant dwarfs every other planet in our cosmic neighborhood. If Earth were the size of a grape, Jupiter would be more like a basketball. But despite its size, this colossal planet spins on its axis at an incredible speed, completing a full rotation in just under 10 hours. That's less than half the length of a day on Earth, even though Jupiter is over 11 times wider. Jupiter is no ordinary gas planet. Beneath its swirling clouds lies a world of immense pressure, searing temperatures, and mysteries we are only beginning to uncover. But before we explore the secrets of its atmosphere, core, and magnetic field, it's important to understand Jupiter's key role in the formation of the solar system. Jupiter's immense size and gravity have earned it the nickname, the guardian of the solar system. In its early days, Jupiter's gravitational force shaped the formation of other planets and objects. It is believed that Jupiter's massive influence helped shield the inner planets, including Earth, from a bombardment of asteroids and comets. Without Jupiter, the early solar system might have been a much more chaotic and dangerous place. But Jupiter's role as a protector isn't just about gravity, it's about location too. Jupiter is the closest gas giant to the Sun, positioning it as a kind of gravitational gatekeeper for the rest of the solar system. Its immense pull acts like a cosmic vacuum, capturing and deflecting potentially dangerous objects that come too close to the inner planets. Asteroids and comets that might have struck Earth have often been caught in Jupiter's gravitational web, pulled into its orbit, or flung out into the depths of space. Even today, Jupiter continues to play a key role in shaping the trajectories of celestial bodies. Its massive gravitational influence extends far beyond its immediate surroundings, pulling on asteroids, comets, and even the smaller planets. In many ways, Jupiter is responsible for the relatively stable and predictable system we inhabit today. Without its immense presence, Earth's history might have taken a very different path, one filled with frequent asteroid impacts and potentially much less favorable conditions for life to emerge and thrive. But while Jupiter protects the inner planets, it also has a dynamic system of its own. And at the heart of this system is the planet's incredible atmosphere, a swirling, storm-filled wonderland of gases that have fascinated astronomers for centuries. Jupiter's atmosphere is as complex as it is beautiful. At first glance, it's easy to be captivated by the planet's colorful bands of clouds and massive storms. But beneath these stunning visuals lies an intricate dance of chemistry and physics. The outer layers of Jupiter's atmosphere are made up mostly of hydrogen and helium, the same elements that make up stars like the Sun. However, unlike stars, Jupiter's hydrogen doesn't undergo nuclear fusion, which is why the planet remains a gas giant rather than a second sun. As we look deeper into Jupiter's atmosphere, we find that its clouds are organized into belts and zones, alternating bands of light and dark that circle the planet parallel to its equator. These bands are driven by high-speed jet streams that can reach speeds of up to 600 kilometers per hour. The lighter bands, called zones, consist of rising gas, while the darker belts are where gas sinks back down. This constant movement creates powerful storms, the most famous of which is the Great Red Spot. The Great Red Spot is perhaps Jupiter's most iconic feature, a giant storm twice the size of Earth that has been raging for at least 350 years. This massive storm is one of the most mysterious phenomena in the solar system, and scientists are still trying to understand why it has lasted so long. Over the past few decades, however, researchers have noticed that the Great Red Spot is slowly shrinking, leading some to wonder whether this centuries-old storm may eventually fade away. But the Great Red Spot is only one of the many storms that churn in Jupiter's atmosphere. As we move closer to the poles, we find even more complex weather systems, including storms that produce auroras, spectacular displays of light caused by Jupiter's powerful magnetic field interacting with charged particles from the sun. These auroras are far more intense than the northern and southern lights seen on Earth, shining brightly in Jupiter's upper atmosphere. The deeper we go into Jupiter's atmosphere, the more extreme the conditions become. At a certain depth, the pressure becomes so great that hydrogen gas is compressed into a strange state of matter called liquid metallic hydrogen. This exotic substance is believed to conduct electricity, which could explain Jupiter's incredibly powerful magnetic field. Jupiter's magnetic field is the strongest of any planet in the solar system, even surpassing Earth's by a factor of 20,000. This enormous magnetosphere extends millions of kilometers into space, far beyond Jupiter's moons, creating a kind of invisible shield around the planet. But while this magnetic field protects the planet from cosmic radiation, it also generates dangerous levels of radiation itself. Jupiter's radiation belts are some of the most hazardous places in the solar system. The intense radiation in these regions is so powerful that it can quickly fry unprotected spacecraft and would be lethal to any human who ventured too close without proper shielding. In fact, even robotic missions sent to study Jupiter must be carefully designed to survive the planet's harsh radiation environment. But Jupiter's magnetic field doesn't just trap radiation, it also interacts with the planet's moons, creating spectacular displays of energy. For example, the moon Io, which is the most volcanically active body in the solar system, constantly spews sulfur and other gases into space. These particles become ionized and are caught in Jupiter's magnetosphere, creating massive electric currents between the planet and its moon. This interaction fuels some of the most powerful auroras in the solar system, lighting up Jupiter's poles with brilliant displays of light and energy. While Jupiter itself is a fascinating world, its moons are just as intriguing. With at least 79 known moons orbiting the giant planet, Jupiter's moon system is a world unto itself. 4 of these moons, known as the Galilean moons, are especially noteworthy: Io, Europa, Ganymede, and Callisto. Let's start with Io, the closest of the 4 Galilean moons. Io is a world of fire and brimstone, dominated by massive volcanic eruptions that constantly reshape its surface. In fact, Io's volcanism is so intense that its surface is continually covered in fresh lava flows, giving it a unique appearance unlike anything else in the solar system. The intense tidal forces from Jupiter's gravity, combined with the gravitational pull of the other moons, create immense friction within Io's interior, heating the moon from the inside out and fueling its constant volcanic activity. Next, we have Europa, one of the most promising places in the solar system to search for extraterrestrial life. Europa is covered in a thick layer of ice, but beneath that icy shell lies a vast ocean of liquid water, an ocean that may be twice the size of all the Earth's oceans combined. Scientists believe that this ocean could harbor life, possibly in the form of microbial organisms similar to those found around hydrothermal vents on Earth. If there is life on Europa, it would exist in complete darkness, sustained by the heat and energy from the moon's interior. NASA and other space agencies have plans to send future missions to Europa to explore its icy surface and search for signs of life in its hidden ocean. Moving outward, we come to Ganymede, the largest moon in the solar system. Ganymede is so big that it's even larger than the planet Mercury, and it's the only moon known to have its own magnetic field. Like Europa, Ganymede is thought to have a subsurface ocean, and scientists believe that it may also have the right conditions to support life. Recent data from NASA's Juno mission suggests that Ganymede's ocean could be layered, with different depths and compositions, creating a complex and dynamic environment beneath its icy surface. Finally, there's Callisto, the outermost of the Galilean moons. Callisto is an ancient and heavily cratered world, with a surface that dates back billions of years. Unlike Io, Europa, and Ganymede, Callisto shows little evidence of internal activity, and its surface has remained largely unchanged since its formation. However, Callisto is still an intriguing moon because of its potential to host life. Scientists believe that Callisto may also have a subsurface ocean, though it is likely much deeper and less accessible than the oceans of Europa and Ganymede. Europa, with its icy surface hiding a vast subterranean ocean, has long captured the imagination of scientists. Its cracked and fractured exterior is a sign that something dynamic is happening beneath the surface, suggesting an active world lurking below. The immense fissures and ridges that crisscross Europa's landscape hint at tectonic processes or some form of activity within the moon's thick ice shell. But perhaps the most exciting feature of this distant moon is the tantalizing possibility of liquid water, potentially harboring life below its frozen crust. Plumes of water vapor have been detected erupting from Europa's surface, pointing to the fact that something is stirring beneath. These geysers likely originate from the subsurface ocean, breaking through cracks in the ice and venting into space. Europa's ocean, estimated to contain more water than all of Earth's oceans combined, could be one of the most promising places in our solar system to find alien life. The potential for life in Europa's ocean is bolstered by what we've discovered in extreme environments here on Earth. In places like hydrothermal vents at the bottom of our oceans, where sunlight never reaches and conditions are incredibly hostile, life thrives, feeding off the chemical energy produced by the Earth's interior. Europa may have similar conditions: volcanic activity on the seafloor, providing the necessary heat and chemical energy to sustain simple forms of life. If this is the case, Europa's ocean isn't just a dark, frozen abyss. It might be teeming with life. NASA's upcoming Europa Clipper mission will provide an unprecedented look at this enigmatic world. Scheduled to launch within the next decade, this mission will conduct a series of flybys, collecting detailed measurements of Europa's icy surface, studying the plumes in more depth, and probing the moon's interior with sophisticated instruments. If signs of life or the right conditions for life are detected, it would be one of the most profound discoveries in human history, evidence that we are not alone in the universe. Europa's icy expanse might conceal answers to questions humanity has asked for millennia. Are we alone? Is there life beyond Earth? Ganymede stands out not only because of its size, it's the largest moon in the solar system, but also due to its internal complexity. Unlike any other moon, Ganymede generates its own magnetic field, a feature typically reserved for planets. This field likely originates from a liquid iron core at Ganymede's center, producing a magnetic dynamo similar to what we find on Earth. The interaction between Ganymede's magnetic field and Jupiter's powerful magnetosphere creates beautiful auroras at the moon's poles, an otherworldly light show that parallels our northern lights. But Ganymede's magnetic field is more than just a curiosity. It's a window into the moon's interior. Recent studies suggest that beneath its frozen surface lies a deep, salty ocean, sandwiched between layers of ice and rock. This hidden ocean, much like Europa's, might contain more water than all of Earth's oceans. What's more, this ocean might be warm enough, thanks to tidal heating and possibly hydrothermal vents on the seafloor, to support life. Exploring Ganymede's ocean, however, poses unique challenges. Its thick ice crust, which could be as much as 100 miles deep, acts as a formidable barrier between the surface and the mysterious ocean below. Despite this, future missions like the European Space Agency's JUICE, Jupiter Icy Moons Explorer, will aim to learn more about Ganymede's structure. By using radar to peer through the ice and measuring the moon's gravitational and magnetic fields, scientists hope to unlock the secrets of this icy giant. Could Ganymede's ocean, like Europa's, be a potential habitat for life? The answers may reshape our understanding of where and how life might arise in the universe. Callisto, the outermost of Jupiter's 4 large moons, is often overlooked in favor of its more dynamic siblings. Unlike Europa and Ganymede, Callisto's surface is heavily cratered and geologically inactive, leading some to dismiss it as a dead world. However, Callisto holds a unique place in the solar system as a time capsule, preserving the conditions of the early solar system. Its battered surface has remained largely unchanged for billions of years. offering a glimpse into the processes that shaped the planets and moons long ago. Despite its ancient appearance, Callisto has some intriguing secrets. Like Europa and Ganymede, Callisto may harbor a subsurface ocean, although it is likely buried even deeper beneath the surface. The absence of significant geological activity means that this ocean, if it exists, has been undisturbed for eons, potentially preserving clues about the moon's early history and the broader evolution of the solar system. Moreover, Callisto's low radiation levels make it a more suitable candidate for human exploration than the more radiation-bathed moons closer to Jupiter. NASA has considered Callisto as a potential site for a future human outpost. Its stable surface and relative safety from Jupiter's intense radiation make it an appealing location for long-term missions. Establishing a base on Callisto could serve as a stepping stone for future exploration of the outer solar system, allowing humans to venture further into the cosmic frontier. From Callisto, we could study the other moons of Jupiter, as well as the giant planet itself, unlocking new mysteries about the formation and evolution of gas giants and their satellite systems. Callisto may not have the dramatic ice plumes of Europa or the magnetic mysteries of Ganymede, but its quiet endurance and preserved history make it an essential piece of the puzzle in understanding our solar system's past and its potential for supporting life. Jupiter, the king of the planets, looms large not only in size, but in its influence over the entire solar system. With a mass more than twice that of all the other planets combined, Jupiter's immense gravity has shaped the orbits and destinies of countless celestial bodies, from asteroids to moons. But Jupiter isn't just a massive ball of gas. It's a dynamic world in its own right, with a complex atmosphere, swirling storms, and powerful magnetic fields. The most iconic feature of Jupiter is the Great Red Spot, a colossal storm that has raged for centuries. This massive vortex is large enough to swallow Earth whole, and despite its longevity, it shows signs of gradually shrinking. The red spot is just one of many storms that churn through Jupiter's atmosphere, where bands of clouds move in opposite directions, driven by powerful winds that can reach speeds of over 300 miles per hour. Beneath Jupiter's turbulent clouds lies an enigmatic interior. While the planet is mostly composed of hydrogen and helium, similar to the Sun, it is believed to have a dense core made of heavier elements. Surrounding this core is a layer of metallic hydrogen, where the intense pressures turn hydrogen into an exotic form that conducts electricity like a metal. This layer is thought to be the source of Jupiter's powerful magnetic field, which is the strongest of any planet in the solar system. Jupiter's magnetosphere extends far beyond the planet itself, creating a vast bubble of charged particles that stretches millions of miles into space. This magnetic field not only traps radiation, but also plays a key role in shaping the environment around Jupiter's moons, particularly the innermost moon, Io. Io's volcanic activity, driven by the intense gravitational forces exerted by Jupiter, feeds material into the magnetosphere, generating powerful radiation belts and auroras that illuminate the gas giant's poles. Jupiter's sheer size and gravitational dominance have also influenced the evolution of the solar system. Its presence likely played a role in shaping the orbits of the other planets, and it may have helped protect the inner planets, including Earth, from asteroid impacts by deflecting or capturing wayward objects. However, Jupiter's gravity has also directed some asteroids and comets toward Earth, making it both a protector and a potential threat.